Hello everyone. In today's session, we are going to study an important and commonly used demodulation technique of AM, so that is envelope detector. So in envelope detector, we consist of a diode which is acting as a switch and an RC filter. The input to a envelope detector is amplitude modulated wave, which is denoted by S of t. It consists of a source resistance and a load resistance. So, depending on the switching action of the diode, that means depending upon whether the diode is forward biased or reverse biased, forward and reverse biasing of the diode depends upon the input signal S of t. That is, S of t is nothing but amplitude modulated wave. So what will happen during the positive half cycle? See, you can see the module amplitude modulated wave here and the message signal. So during the positive half cycle, of the wave, the diode is positive, the diode is forward biased. So whenever the diode is forward biased, we are getting the resultant output. I am writing the resultant output. Write the envelope first. What will happen during the positive half cycle? I am getting the output. And what will happen during the negative half cycle? So during the negative half cycle of S of t, diode is reverse biased. So diode is reverse biased during the negative half cycle. So whenever it is reverse bias, it is acting as a open switch and there is no path for the current to flow. So that means we will not be getting output during the negative half cycle. So during negative half cycle, I will not be having any output. So once again, during the positive half cycle, there is a output. So this is how the wave continues. That means during the positive half cycle of the modulated wave, I am getting the output. During negative half cycle, since the diode is reverse bias, it is acting as an open switch and I will not be getting the output. Now coming to the action of RC filter. What will happen during the positive half cycle? The positive half cycle, the diode is forward bias and the capacitor charges to its value. That means that during the positive half cycle, the capacitor charges to its. So whenever the voltage is lesser than its peak voltage, then the diode will be reverse bias and the capacitor starts discharging. The capacitor starts discharging unless and until it is finding the next positive. So once again, whenever the input is reducing, capacitor discharges. So whenever it is finding the peak of the wave, it is charging. This process continues. That is charging and discharging of the capacitor. So as a result, whatever the resultant wave which we get from the charging and discharging action of the capacitor, RC filter, similar to our message. So when we take only this is similar to message signal M of t. So in order to ensure fast charging and the slow discharging, we have to design RC filter such that RC value should be in between 1 by Fc and 1 by Fm, where Fm is the frequency of the message signal M of t and Fc is nothing but the carrier frequency. So in order to ensure the fastest charging and the slow discharging of the capacitor, we have to take the values of R and C such that it is in between 1 by Fc and 1 by Fm. I hope you have understood.